So thank you very much. So I'm really excited to talk about the tool that we have been working on over here in Ireland. For search with regards to COVID-19 as exploratory search system for taxonomies. So let me just do the next. I don't know why next is not working. Okay, all right. So the challenge that we have with this type of problem is there is a lot of research that gets published each year, even on daily basis. So there is an information overload problem. And then the main issue is how to keep up and explore articles when it comes to pandemics such as COVID-19 in a quick way. So it's more like a problem where we are trying to find needle in the haystack kind of an issue. So the motivation was to develop a system that facilitates practitioners and medical researchers to focus on COVID-19 by making use of their time in a nice way. So the idea was to develop an exploratory system, information retrieval system, that can help them speed up the process of finding the correct things that they're looking for, or something which is which they were overlooking. So from the previously published literature, or something that they can reuse. So the solution was we came up with an idea that what we can do is we have a previously developed technique, because it was a kind of a race against the time. Can we use something which was already developed? So instead of you can't just do a fundamental research, but instead at this point of time it was more required to apply the research. So we had previously developed a technique called EVE, which is an explainable vector based embedding technique that utilizes DBpedia. The component of it being explainable was something that we were looking for while we were developing this system. So if we can explain the results using some explainable ways, that could be really useful for a search system. Then we adopted this technique on MASH. MASH is actually medical subject headings besides DBpedia, because that would be really useful. DBpedia, when it comes to knowledge bases, DBpedia is more like generic, whereas when it comes to MASH and other taxonomies which are out there for medical sciences, that could be really useful for when it comes to COVID-19. So the next thing was we then think about can we incorporate some query expansion methods, and while we do that, can we explain those results and as well as explanations, and then somehow tie the links to lots of articles that were published on daily basis in some sort of structured way. So the strength of the system is, first, it can expand query to increase the recall. That means you can have lots of results. If you're contrived over a result set, it will increase the result set using various techniques. So we are welcoming information overload, but then once you are welcoming that, next thing is, can you link them in appropriately so that they could be quickly browsed? So the next thing was, once we do this, can we explain the query expansion process so that we can show the user who's using the system what terms were added and how automatically new weights were assigned to them. And if they're happy with it, or if they're not happy with it, they can then tamper with the expansion as they like. Finally, arrange the results according to the phases that we found from the retrieved result set, and arrange them categorically so that they could be navigated in an appropriate way. So this is kind of the system architecture that we have, the foundation of it at least. So we have a crawling side of it where we do the data preparation, where we do all the pre-retrieval steps, such as identifying whether there is a drug, whether there is a route being mentioned in the article, on all these kind of things done at the pre-retrieval, at the indexing time. Then we index them. Then we have web interface where user can issue the query, select a method that they would like to use, and then on the basis of that, highlighting is performed and queues are generated, which then eventually help us refine the query session and an entire session. This is how the search interface would look. It currently looks like. So you have like, it's kind of a standard search system, but there are additional evidences over here. For example, you can see there are various expansion strategies up there. One is making use of mesh, which is, as I explained, so we can apply on mesh. Or we also have pulled information from mesh synonyms, DBpedia and its synonyms, which is based on Eve strategies. And then there is also rule-based, which is actually user-defined taxonomies, which could be custom to medical agency or any user base who is using it. So on the basis of that, whatever queries are issued, expansions are performed using mesh and other criteria which are selected, but also explains what are the new additions of the terms and what are the weights that are given to those terms, and as well as if there is a rule, for example, there is a Boolean operation and an or, can we pull out that as well or not? This is also explained over there. Once that is done, so the user can know like how the expansion is made and how the terms are weighted. If they're not happy with it, they can unselect this and expand it, the query by themselves by taking that as a suggestion. Afterwards, you can see there is also some facets which are shown over here, and these facets, imagine like there are like 200 results which are retrieved. There will be 15 facets or 15 in another way we can say different topics that were extracted automatically on the fly when the query was issued. So it's a post-retrieval step where these categories are extracted automatically, and then they are linked to the article. So if one of the facet is clicked, then of course the results will change to the facets that indicates those results. So it helps, like imagine like if you issue a query and there are 15 threads of it, then those 15 threads could be easily navigated instead of you skimming through 100 and seeing if there is a pattern or not. So query expansion, why was it useful? It increases the recall, helps people in science to explore and exploit when you're not certain about what you're looking. Then of course it makes sense to increase the recall, which is the case for the COVID-19. Why different strategies for query expansion? Because they help user to pick, mix and merge whatever they need for the task or mixture of tasks or type of query needs. It helps with the completeness of retrieval results. So imagine like when you're looking for something and you don't know what you're looking for, perhaps increasing the recall and then bringing it together in an organized way, such as facets, could be very useful. Again, just to give you a little bit of a glimpse of how that technique works, we have Wikipedia category graph structure, which is utilized by DBpedia, and we use the same strategies for mesh as well, which would be employed for any sort of taxonomy, where you have articles such as, let's imagine if an article is on COVID-19 and there is an article on children, there could be in-linking between the articles on the Wikipedia, and likewise, it will be mentioned inside the categories of different categories. And then we try to maximize if those two terms were mentioned inside the query box. We try to maximize the categories that links them together and use them as an evidence for query expansion. So we have adopted what Eve essentially does this is use the Wikipedia category graph structure, which we use through DBpedia, and same strategies employed on mesh and other taxonomies as well. What it does is, given the fact that you have a query in mind or a concept in mind, such as pasta, as you can see, it will find the most appropriate category that it links to by using the Eve strategy, which is cited towards the end of this slide as a reference. Where it simply pulls that this is linked to this category and this category with this strength, which we essentially utilize to generate as a suggestion for the query expansion. Again, how does it work? Imagine there is an article, then we simply propagate the score into the structure, and utilizing the score that from different articles. For example, if the query was composed of children plus COVID plus let's suppose side effects or something like that, then whatever maximizes those categories in the category structure, those categories are considered to be terms that we will use for query expansion. Then facets, because they helps us arrange the results. So for instance, like they are the extracted topical terms that are extracted on the fly from the retrieved result set to bring structure to the results. This is where we apply biased COVID page rank strategy to extract them on the fly. How do we do that? So we extract the noun phrases from the retrieved result sets, which forms the nodes. Then nodes are further deduplicated using semantic synonyms such as flu and influenza are treated as one. We have varieties of those taxonomies such as DBpedia mesh and also user define. Then the edge weights, or the edge, first of all, the edge noun phrases that appears within a certain window distance forms the edge. So for example, like COVID and children, if they co-appear in a document in a close proximity, there will be an edge between children and COVID then. After we have this, we simply run the PageRank equation to get what are the most informative nodes from the corpus. So how do we select the edge weights? We select the edge weights by inverse of noun frequency distances, significant terms retrieved on the results set using chi-square tests of independence, also the normalized frequency of the noun phrases, which is document frequency, which is how popular it is in the document frequency, and then distribute the scores which were retrieved. This is how, again, once you click on the facet, it highlights, for example, influenza is selected over here, and it highlights flu and influenza. Flu is synonym, of course. So, and then it navigates to those results. Nature of development, it was very iterative. We listened to them. We provided them with more than one solution because we don't know what was working for who, and maybe their users have different kinds of needs. So one user was satisfied with one kind of result, another was with the other. So for this pandemic, we identified providing more than one solution is useful. We also thought about like aiding the computer instead of replacing it from the loop was the right approach. So that's all. Thank you.
Okay, thank you for your presentation. So I was wondering, is this tool public? Like, if I want to make a search by myself, can I do it?
At the moment, it is not, because it is with the funding agency at the moment that funded it. We hope once it's published and once we settle down this, we can make it public.
Okay, I was wondering another thing. So after all this data collection and information retrieval, did you do other type of externalities, like to understand if there were more prominent topics, or on the contrary, if there were like topics about COVID that were left apart?
Well, again, because we were concerned with temporal aspects of kind of like, it's very similar to event detection kind of a problem where you have like sometimes emerging out between some months and sometimes dying out afterwards. So I mean, it's quite temporal. So because it keeps on referring, it depends upon.
We can't hear you very well.
Yeah, I'm saying like there were terms that were found useful, which were not being accuracies when they were trying it out, and they were cited by the previous results as well, like the previous published results. Can you hear?
Yeah, I mean, it was fine for the last part, thanks. And I have a last question. Did you get any feedback from practitioners that have been using the system? So, or did you get any kind of feedback about this platform?
Yes. Yes, so they like the idea of query expansion and explanations, because they had previous systems where the explanation where some of the expansion was performing, but they don't have the flexibility to choose from them. And also because we brought in explanations around like not just dealing it as a black box. They like the idea of having the query expansion well, I also like the idea of adding their own rules as a taxonomy for query expansion, because each user can use that for personalization, which is quite useful for them. Yeah.